Let's now consider a confidence interval problem involving a small sample. We have 14 chipmunks that we've measured the weights, and the question is to find the 90% confidence interval for the average weight. Before getting started on the computations, we first note that the method that we're going to use, the t-interval, only works if the data comes from a normal distribution or comes from something that's plausibly close to a normal distribution. So to check that the data comes from something that's close to a normal distribution, we use the probability plots that we saw back in lecture number 10. The first step is we order the data. So let's sort these things. So we have from smallest to largest. And also we put over here the ranks of the data. So we fill down from 1 to 14. And then we, over here, put the rank number minus 0.5 divided by 14. And what this will do is give me percentiles, basically, between a little bit more than 0% to a little bit less than 100%. The next thing we do is add a new column that gives us the percentiles for these probabilities off the normal distribution. And I mistyped it, so that should be B1. And so lastly, we visualize this by adding the plot. And we see that the data does appear to reasonably follow a straight line. Let me change the axes on the y-axis to get a little bit more detail. And we do have data that reasonably follows something that's close to a straight line. And so the t-distribution is justified for this particular data set. So with that as a prelude, we can now turn to the problem at hand, which is actually computing the 90% confidence interval for the data. So if there's the data we still have, we still need to compute the average of the weights, as well as the standard deviation for the weights. And we recall that to find a 90% confidence interval, the picture is that we have a t-distribution. And because I have a small sample, it is a t-distribution with 13 degrees of freedom. And I want a centralized confidence interval, so I want 90% of the area to lie in the middle, which leaves 5% in the right tail, as well as 5% in the left tail. So using the notation that we use in class, the percentile is denoted T 0.05, comma 13. That's the number that's going to appear in the distribution. And our confidence interval will have the form x bar plus or minus the t value times the sample standard deviation divided by the square root of n, where this t value is the same thing as the number that we find on the t-axis here. Okay, so with that as prelude, the x bar is right here, 8.764. T is here, and so the standard deviation is here. The t-distribution, so let me start marking this, that's x bar, so that's the mean, that's the standard deviation. T is going to be equal to t dot inv, and I type in 0.9513 using Microsoft Excel. I believe the command is invt on the TI-84 calculators and up. And the reason we have 0.95 is so that 95% of the area lies to the left of the mark that I see here on the right. So I get a positive number, 1.77093. And so the margin of error will be equal to the t-value times the standard deviation divided by the square root of n, which in this case is square root of 14. So 0.3602. And so finally we have that the confidence interval will be 0.76 plus or minus 0.36 when I round to 2 decimal places.